So let's find some more domains and look at all of the types of notations. So I said that there were 3 notations, and that's actually not true. There's actually 4. This is also a graphical representation of my solution set. And so again, we have multiple ways, and you're going to need to know the specific ones that you're going to be asked about. So this is a graphical. All right, so I'm going to add that. All right. Oops. So let's look at a couple more. So say we have the function f of x, and I put a 1/2 in front of my radical and just say the square root of 4 minus x. Right. Again, your procedure is going to be to start with the radicand and make sure that that is greater than or equal to 0, and then start solving. So I'm going to move my 4 over, which is going to create it to be negative. And now when I divide, though, by this negative, I have to remember that when you divide by a negative, it flips the direction of the inequality symbol. So when I write this as x, instead of writing it as greater than or equal to, I have to write it as less than or equal to 4. And so that's a key rule of inequalities, that dividing by a negative changes the direction of the inequality symbol. Right? And so again, I'm going to box this as my inequality notation. Right? Then I'm going to write my other types of notations. All right? I'm going to write my graphical first. All right? And so again, that's just a quick little sketch. And really, I usually just place the number in the middle so that I can see which direction I'm going to go. And again, because of the equal to part, now I want all the values for x that are less than 4, which means I'm going to go this direction. And again, that's going to help me build my interval notation, because now when I move from left to right, I have to go from negative infinity up to 4 and including 4. All right, so you're going to start noticing that whichever side the arrow goes, all right, that's going to be your start and your stop, or your start and your stop for your interval notation. And then again, my set builder. And set builder uses this. So that's my little set, all the values for x such that x is less than or equal to 4. Right. So sometimes you don't get a linear equation inside this radical. And so that's kind of where we want to start looking at some trickier ones. All right, so let's look at one. Let's just write this as the square root of x squared plus 9. Right. Now, when I take this radical and I set this to be greater than or equal to 0, right, if I go to start solving this and I move my 9 to the other side, I'm going to be trying to take a square root of a negative. And that can't happen. Right? So I'm not allowed to take the square root of a negative. Well, that's actually okay. All right? I'm just saying that like, this part right here is something that I'm not allowed to do. So what happens is that if I think about this expression right here, no matter what value I put in for x, when I square it, this will always be positive plus a positive, which means this will always be a positive value. I am not going to exclude anything at all from this expression. And so when we're talking about my notations, really I get all real numbers, meaning I can put anything I want in there. I mean, graphically, that means that I have a graph, right, where I get to use everything. There's no restriction. Right? And so the way that we do that in terms of interval notation is we go from negative infinity to positive infinity, which tells us we get to use everything. There's nothing I have to throw away or get rid of like the others. Right? Now that's not always going to be the case. Right? That only happens because underneath this radical will always be positive. Right? But the trickier ones are what happens when that's not true. For example, say I get negative 3 times the square root of x squared minus 4. Right? So because of this minus sign, there are values that I can put here and that when I subtract 4 will be negative. So I still need to go about this in the same manner and take my radicand, set it greater than or equal to 0. And I can see that now when I move my 4 over, I could actually do that. Now the problem is that this is going to lead me down a weird path. All right, I don't want to be using the square root property on this. You're not allowed to use the square root property with an inequality symbol. All right, and so if I do that, it's going to give me a weird answer that's not really true. And so what I want to do is I want to not go down that road. I want to actually leave my variable and my constant on the same side, and I want to factor instead. All right. You want to factor. So really, what you want to do is you want to say this is a difference of squares, which means that I'm going to have two binomials, right, where the first term comes from half of each of the squares, and the second one comes from the other one. Now, I'm going to need to make a little test chart. All right? And really what I need to test is I need to find values of where this is going to be true. What's going to happen is because I have different factors here, it's going to create intervals of different chunks along my number line. All right? So I'm going to put my two symbols. But now I have to think about when is x plus 2 equal to 0 and when is x minus 2 equal to 0. And what that's going to do is it's going to give me a couple values here on my number line, not just one. So I want you to see that your number line is broken up into separate intervals. I have this interval going from negative infinity to negative 2. I have an interval in the middle from negative 2 to positive 2. And I have this other interval from 2 to infinity. And you have to figure out which one or two are going to be your true statement. And so you're going to pick a test point. All right? So what I'm going to do is I'm going to test what happens when I plug in, say, negative 10. So a number in this interval. I need to see, is this statement going to be true? And here I'm going to test 0. It just has to be any number in that interval. So pick one. And then I'm going to test, say, positive 10. And so what I'm going to do is I'm going to plug this number into this expression and say, is that in fact greater than or equal to 0? Right? So I need to say, is negative 10 plus 2 times negative 10 minus 2, I want to know, is that greater than or equal to 0? Right? Now you can do it on your calculator, or you can just do the math and think, this right here is going to be a negative number times another negative number, and a negative times a negative is positive, which means that this is going to be one of my true statements. This is going to be one of my intervals that if I pick any number in here will make that inequality true. I mean, you can actually do the math and say, you know, negative 8 times negative 12 and figure out what number that is, but regardless, a negative times a negative is greater than or equal to 0. Right? And then I'm going to come down here, I'm going to test 0. So 0 plus 2 times 0 minus 2, and I'm testing this. Well, this is a positive times a negative, results in a negative number which is not greater than or equal to 0. Right? That's going to be a problem. So here what I have is I have a true statement and I have a false statement. And now I'm going to check this one. So again, now is positive 10 plus 2 times 10 minus 2 greater than or equal to 0. And again, I get a positive times a positive, and that's also true. Right? So what we have is we have a number line here where I have more than one section of the number line, which is going to be in my domain. So let's look at what this looks like in terms of interval notation. Right? In terms of interval notation, what that means is that I get to use starting from negative 2 and going towards negative infinity, or I get to go from positive 2 towards positive infinity. And so we always go from the most negative to the most positive. So again, this interval is going to be from negative infinity to negative 2 and gets to include that value. And I'm going to union that starting from 2 to infinity. And so what this little union symbol does is it says there's a break in between these two numbers on the number line where there is a chunk that does not get to be used. Right? So this is a little bit more like what we want to be able to use in terms of interval notation. Inequality notation is a little bit harder because you have to think about how you're going to take this and write this as an inequality. So I want all the values for x that are less than or equal to negative 2, or all the values for x that are greater than or equal to positive 2. So I need to think about how I'm going to write those, and usually we focus mostly on interval notation when that's the case.